Hello everyone. So today we'll be solving another LeetCode hard problem. Minimum cost to make array equal. So the problem states that we are given two array nums and cost, each consisting of n positive integers. Now we can do the following operation any number of times. So in one operation we can increase or decrease any element of the array nums by 1, and the cost of doing that operation at the ith element will be cost of I. Now we need to return the minimum total cost such that all the elements of the array nums become equal, and the length of both the arrays can be up to 25, and the result is means generated in a way that such that it fits in long. Okay, so for example here what we can do here means operation in one operation we can either do nums of I means nums of I minus minus, or we can do nums of I plus plus, and cost will be cost of I. Okay, so let's try for the given input. So here we have 1 3 5 2. So let's try to make all elements as 1 1 1 1, since we need to make all elements equal. Hence the cost here will be, this is same, so 0, plus this is decreasing by 2, so 2 times we have applied operation here on 3, so it will be 2 into the cost 3, plus from 5 we are going to 1, that means 4 times we have applied operation here, so it will be 4 into 1, and plus for 2 we have applied one operation, so it will be 1 into 40. As you can see, like it will be 34, 6 plus 10 24. Okay, now let's try to make all elements as 2. So we will see, like this element we have applied one operation, so it will be 1 into 2. Now for this element we have again applied one operation, so it will be 1 into 3, plus for this element we have applied 3 operations to make it 2, so it will be 3 into 1, and for this element we have not applied any operation, so it will be 0. So this will give us like 2 plus 3 plus 3, which is 8. Now let's try to make all elements as 3. So what we will get, we get 2 into 2, plus for this 3 0, plus for this 5 2 into 1, plus for this 2 to 3 it will be 1 into 14. So it will be simply 4 plus 2 6 plus 14, so it will be 20. As you can see, like making it a value 2 was feasible here. With minimum cost we were able to make all the elements as 2, and hence 8 is the output here. I hope that means how we are applying the operations is clear now. For example, if we have another input 2 2 2 2 2 2, so since it already has all the elements as equal, we will not be applying any operations, and hence the cost remains the same, means it remains 0 only. Now what observations do we need to make? Okay, so suppose we have like this array nums which has two elements x and y, and the cost is a comma b. Now there are two possible ways. Suppose there are two possible ways. If we try to make it x, so it will be x comma x, or we try to make this y, means so it will be y comma y, or we suppose here x is less than y. Okay, now and suppose we do not make element which is part of the array. So suppose since x was less than y, so x to y, this was the range. Suppose we make it equals to some value between x and y. So let's make it k comma k. Now let's analyze the cost that will be required in each of these cases. So for x comma x, the cost will be 0, plus it will be b into y minus x. Okay, for this case, for y comma y, it will be a into y minus x plus 0, and in this case it will be k minus a, k minus x into a plus y minus k into b. So now what we can see here is, let's rewrite this. So this is by minus bx, this is ay minus ax, and this is nothing but ka minus ax plus by minus kb. So this is nothing but if we take k common, so it will be a minus b, and then if we take means then we have simply minus ax minus b. Okay, so what we can observe here is like here we try to make it all elements equals to x. Now we have this cost function a comma b. Suppose here a was less than b. Okay, so which of these approaches would be the most optimal way of making all elements equal? So if we try to follow this approach here, since a is less than b, here we did not means we make y as x, right? So since this by b was greater, we means this value will be greater than this value. Alright, b into y minus x would be greater than a into y minus x because a is less than b here. Okay, and if we observe this case here, what we are doing is here we utilized some operations, means some operations for k minus x and then some operations for y minus k. So this will also be greater than a into y minus x because since a is less than b, so for this was the range of x to y. So for this range we are using cost as a, and for this range we are using cost as b. Hence this sum will always be greater than if we used a for the overall cost, right? So hence what we can observe is means making any element means which is not a part of the given array is not feasible here, right? Because if we since we will only apply means make the elements which has a cost is smaller, right? So we will not make it equals to any element which is middle of k. Either we will make it x only, xx, or we can make it yy only. So hence this is the observation that we derive. Like what is the observation? Like make to minimize cost, make the elements equal to an element which is part of array, right? To an element which is part of array. So this is what we'll do here. We will, to minimize the cost, we'll be making the elements equals to an element which already exists in the array. So I hope this logic is clear why we are choosing an element which is already a part of the array to means make it finally equals to. Okay, so now this problem now finally reduces to like classical meeting point problem or weighted median problem. So what I mean to say is, suppose we have an array of like a1, a2, a3 and so on, and now we need to convert it into some element ai only, such that the new array becomes ai, 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 right? And this ai can be a1, a2, a3 or an, means depending on that. So and this ai we need to find, right? What will be the most optimal ai to like use so that we minimize the cost? So this is like a classical variation of meeting point or weighted median problem. Now I will be explaining you the means core logic and proof of how to solve these kind of problems. So let's move on with this. So what do we need to do? We need to find a spot, means we need to find a spot where the number of people to the left is equals to the number of people to the right. So suppose this was the nums array. Okay, this was the nums array a1, a2, an. So we means need to make it choose ai in a way such that if we make all elements as ai, the number of elements on the left and the number of elements on the right are same. All right, the number of means that by number what I mean is the weighted median of these values, means the first time it becomes greater than equals to total sum of nums divided by 2. So what you can see, like what if we try to choose this ai naively as like sum by 2 and try to make it equals to ai, means try to make ai equals to this only. So how, let's prove like why this will be the most optimal output. So for example, let us like let the target value we choose be x. So we had a1 a2 and so on an, and now we needed all elements, made all elements as x. Okay, so what will be the cost? The cost will be here absolute of a1 minus x into cost of 1, then absolute of a2 minus x into cost of 2, and sum of all these values. So the function, cost function would look like something summation I equals to 0 to n minus 1 cost of I into nums of I minus x, where x is the target value that we have chosen. Now for this function, what, how it will look like? It will look like something if we choose x to be like this is the number line. So if we choose x to be here, then obviously for the values on the far right, the this difference value will be larger. Suppose I will try to plot a graph of this function. So suppose the value is this. Then if we try to increase x, definitely, since the means if we try to move x to the right, these differences would decrease only, hence the cost would decrease. So again cost would decrease. If we decrease it, again decrease, 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 decrease. Again if we try to put x here, then from the starting the differences would be very high. So again here also the value would be pretty high, right? And if we try to move the x before, so it will keep reducing. So now we need to like find this, the bottom of the bucket, this where the means the cost will be minimum. So the shape is like a V or a bucket, and the bottom of this bucket is our answer. Okay, now let's try to prove like why we are going with weighted median, or the first element means first ai greater than equals to sum by 2. Why? So let's like we have, suppose the nums array. Okay, nums array, and we are at a particular element, means we have made it equals to a particular element x. So the sum of these values would be, suppose wl, and some of these values would be wr. Alright, so suppose we are at currently position x, then wl denotes the sum of weights of all points to the left of x, and wr denotes the sum of weights of all points to the right of x. Now let's try to find how this function will be changing here. So if we move x like to the right by a distance delta, so we had a1 a2 dot x dot an minus 1 an. Now if we move this x to the right, this was wl sum, and this was wr. Now if we move this x to the right, this wl values would be increasing, right? And how much will it increase? The amount by which we will be increasing this delta. So if we move x by delta, then for all the values it will be like a1 plus delta, a2 plus delta, and so on. So it will be, the overall result will be increasing by, means all the points on the left are now further away. So the cost, means the cost function here will increase by wl into delta. Okay, this cost function we are trying to analyze. And if we, all the points on the right, means if we try to move this to the left delta, then all the points on the right, means in this case only, all the points on the left are now further away, but all the points on the right are now further closer to it. So how it will decrease? So this has increased, and it will decrease by a factor of wr into delta. Okay, so overall means increase or decrease will be this wr delta positive minus wr delta negative. So the net change in cost will be wr minus wl minus wr into delta. Now what will be the various scenarios? Scenarios will be where WL is greater than WR, WL is less than WR, and we'll try to see how optimally we need to choose W and WR so that this cost minimizes, right? So if WL is less than WR, okay, so this was WL X and this was WR. Now what if WL is less than WR? So definitely this WL minus WR will be negative. Hence if you keep moving right, this cost function will keep on decreasing only. Okay, so hence the heavy right pulls us towards it because we have higher values on the right hand. Hence we try to keep x here so that it is closer to the right. Alright. Similarly, if WL is greater than WR, then WL minus WR is positive. If it is positive, if we keep moving right, then the cost will increase only. And so what we'll do, we'll keep moving to the left. Okay, so we went too far, we should move left. Now what will be the optimal case? Suppose we choose it in a way such that WL is similar to WR. Okay, in that case this cost would be tending to 0. So hence the minimum cost will occur exactly at the point where the WL becomes equals to WR. So we had this entire array and we have this WL and WR and overall weight was W. So we want like WL plus WR was equals to W and this WL becomes equals to WR. Hence 2 times WL equals to W. So this WL will be W by 2 only approximately. That's why we have like gotten a proof like choosing the X value as a total sum of these nums array by 2 would be the most optimal way here. So this implies that we need to find the index k where the cumulative weight first exceeds total weight by 2, because we'll take means a1 a1 plus a2 a1 plus a2 plus a3 will go on till a point where the first time this WL becomes greater than equals to overall means sum of all elements by 2, and that will be the index which we'll be choosing for suppose ak, and hence the final x will be ak only. And once we have this x, we'll simply find out the cost as this cost function was cost I into nums of I minus x, and we'll take summation I equals to 0 till n minus 1. Once we know like which number we are making equals to the all the elements, we'll simply take the difference and multiply it by cost of I. So I hope like you get the logic now, like why we are making means choosing the index k where the cumulative weight first exceeds total weight by 2. Why we are choosing this? Because in that case the minimum means minimum cost will occur exactly. So we have analyzed various scenarios. So how we went through the problem? We tried to write the cost function, then tried to move the x far right or far left, and then try to analyze like at what position this x should be chosen so that this cost function reduces. So this is what we are trying to do. We analyzed different conditions of like WL less than WR, WL greater than WR, and finally we got to know that this WL should be like approximately equals to WR. And once we have this, we'll simply find out this index and make all the elements equals to AK, and that will be the minimum cost. So like let's see the code as well here. So I hope the logic now is clear. Now we will be moving to the implementation part. So what we'll do, we are given these two vectors nums and cost, right? So since we need to sort it on the basis of nums, okay, we'll sort it on the basis of nums of I such that we need to find some x such that WR becomes equals to WR. So we need to take into account the prefix means sorted nums only, okay, and then we take the prefix sum of sorted nums. So this is why we have created this vector where for each means at each index we know the nums and we know the cost as well. Now we'll be sorting it on the basis of nums. So on the basis of nums, this will be sorted. Now we take this total weight to find out the overall weight. Okay, and hence we'll find out WL greater than or equals to W by 2. So this W here is total weight here. Now this current weight here will be the prefix sum, the WL here. This median num will be the first element AK, means where it becomes WL becomes greater than or equals to W by 2, and total weight is half weight is this. So we increase the current weight by the second value, the cost value. Okay, and then if the current weight is greater than or equals to half of weight, means half of the total weight that we needed, then the one median would be A of k, means nums of k. Okay, and we'll simply break from the loop. So hence we tried like the weight cost array. We tried to find out in cost array the moment at which the WL becomes greater than or equals to W by 2, and that AK would be choosing in nums array. I hope you are not confused between at what element we are finding out the weights and at what means array we are finding out AK. Now once we have this, we need to make all the elements of nums array as median num only. So we'll do this only. We'll initialize a vector, and at each step we'll calculate nums of I minus this median num into the cost required and finally return the result. So as you can see, like this runs for overall complexity of n log n. Means sorting it would take n log n, and all the other loops are of big of n. Okay. So I hope like you get the logic of how do we approach these kind of like a meeting point or weighted median problems. We try to sort it on the basis of weights, and then making it is equals to the weighted median or making it equals to the average point would be the most feasible way here. And this is what we generally follow. We will find a spot where the number of people to the left equals to the number of people to the right. So what we did was, initially suppose all cost functions were 1, so we'll definitely pick someone here only, right? But since cost function is not 1, it is a, b, c, d, so on, so we need to pick someone such that WL is greater than or equals to W by 2, and this is what we did. And I hope like the proof and everything is clear to you. Now let's try to submit the code as well here. So let's submit it and see how well it performs. So as you can see, like it runs in 7 ms, so it beats most of the runtime. And yeah, the complexity is also fine on the basis of constraints. We had 1e5, so n log n is completely fine. So I hope you got the logic, and if you have any doubts, feel free to comment down and I will be happy to respond. Thank you for watching.